Hello everybody, and welcome to our next video where we will be solving these three tasks. But before I start, I want to tell you that this video is dedicated to one of my students, Yasmin. So I hope you will enjoy it, Yasmin, and I guess and I hope everybody who will be watching this video. So we will be in the first task evaluating these two expressions. In the second task, we will rewrite the expression as a single logarithm. We will try this on these two expressions. And the last task will be using the laws of logarithms to rewrite the expression in a form with no logarithm of a product, quotient, and or power. But before I start, I want you just to remind that these are our three very basic rules or laws of logarithms we will be using. The first one is law of product, the second one is law of quotient, and the last one is the law of logarithms of power. So let's start with the first exercise, which is about evaluating the expression. But before I'll do, I want to make some more space here. So let's have a look on our first expression. And of course, we will try to find like a number when we will evaluate this expression. So first of all, we have to realize that this expression can be rewritten as a logarithm base 2 of 16 to the power 1 over 5 in parentheses. Now we will use law number 3, which is the law of power, and then it would be 1 over 5 times logarithm base 2 of 16. So here we used the law number 3. Okay. Now, if we have a look at this expression, we can simplify number 16 as 2 to the power of 4. So our expression is gonna be 1 over 5 times log base 2 of 2 to the power of 4 in parentheses. Now, as we already know, and I'm missing kind of property of logarithms, which says that logarithm base a of let's say x is equal to y if and only if a to the power of y is equal to x. So by using this property of logarithms, we now come to the expression 1 over 5 times 4, because and let me write it here, logarithm base 2 to the power of 4 must be equal 4, because 2 to the power of 4 is of course equal to the power of 4. So by using this, we already have very nice expression or number. So our result is 4 over 5. Okay, so this is the solution of the first task. Let's find and let's solve the second one. And here we can see that we have the subtraction, so we will use the law of quotient. Basically, we can simplify these as logarithm base 3 of 189 divided by 7, or over 7 if you want to. So we used the law number 2 here. Now if you have a look at these two numbers, and first thing you'll try to think about is if it is possible to divide 189 by 7, and the good news is that it is. The first number you try to think about is number 7, because 7 times 7 is 9, and after that you will try to find it, as you know that 7 times 7 is 49, so if you take away 49 from 189, it's gonna be 140, so it means 7 in 140 is 20 times, so this can be simplified as logarithm base 3 of 27. And as you can now think about our next steps, it's gonna be logarithm base 3 of 3 to the power of 3, and again we use the property of logarithms, which I defined like the last one, so our solution is number 3. This one is really like very easy. Now let's go to the second exercise, but before we go further, let me again make some more space again. So I will move this down, and I will replace the second expression to the right side of the screen. And as we probably will need, and I want you to have in mind these laws of logarithms and the very basic property of logarithms, I will move it here. So let's start with the first expression. And what does it mean to rewrite the expression as a single logarithm? Basically, we want to have a result like a logarithm base 4 of some kind of expression. So by using the laws of logarithms, we will try to let's say simplify this expression. But before I start solving this exercise, I want to ask you to pause the video and try it by your own, because I think you are quite skillful to do it by your own, and then you just come back and watch the video, continue watching the video, and check your results. Okay? I hope that you stopped the video and you tried to solve it by your own. And as I want you to show you how to do this, I will do it right now for you, so that you can check your result. So basically, the very first term of this expression can be rewritten by using the law number 3, law of power. It's gonna be logarithm base 4 of 5 cubed plus logarithm base 4 of 10 minus logarithm base 4 of 7. This is equal to, so in this case we used the law number 3. Okay, now we will use the fact that logarithm base 4 of 5 to the power of 3 is like 125 plus logarithm base 4 of 10 minus or take away logarithm 4 of 7. Now we will use the law number 1. So let's use law number 1 here, which means we will simplify this addition, and this is gonna be then the logarithm of the product. So it's gonna be logarithm base 4 of 125 times 10 sorry, take away logarithm base 4 of 7 equals, now we will do some kind of simplification, which is gonna be logarithm base 4 of 1250 take away logarithm base 4 of 7. Now we're gonna use the law number 2. Okay, and then our result is gonna be logarithm base 4 of 1250 divided by 7. And if you want to evaluate this expression, like having the number as I explained during our lesson. You can do it, but most of the calculators are not able to calculate the logarithms base of 4 or any other than logarithms with basis 10 or e, which is then a natural logarithm. So let's find the final result, and the number. For this we will use the change of base formula. Change of base formula, which basically means that any logarithm of base a of x can be written as a logarithm of any base. For example, and most often you use the base 10, and this is called common logarithm, as you already know. So that's why there is no base of x over logarithm again base 10, which is common logarithm of a. This is one possibility. The same can be applied like for natural logarithm, so it can be written like natural logarithm of x over natural logarithm of a, which basically is also true if you would use any other base, and this can be then written like logarithm base b of x over logarithm base b of a. Okay, the only necessary thing or important thing when you use the change of the base formula is that you use in the numerator and the denominator logarithms with the same basis. In the first case I used number 10 or base 10. In the second case I used base e, and in the last case I used the base of b, which can be any number. But as we already said, the easiest way is to calculate the log 1250 over log 7, and then you will find the solution. So, but now there is only one thing you can do to evaluate this. You should use your calculator and try to calculate log 1250 divided by or over log of 7, and the result is approximately 3.66, and it depends how many decimal places you want to use. In this case, let's use this result. Okay, so we are done here. Now let's try the next exercise, which is this one. Let me put it here, and I hope I will have enough place, but just to be sure I want to make more space. And then yeah, okay, I think this is okay, so that you can see also the laws of logarithms. So this one is equal to what can you do here now is you just take the second expression and you use the law number 3. So this logarithm can be written like log of x minus log of y squared plus log, and you can do it in one step, log of 9z squared the whole to the power of 1 over 2. So we used the law number 3 here. The next step will be simplification, which means this is equal to log of x minus log of y squared plus log of 3z, okay, because this is like the square root of the expression in the parentheses. Square root of 9 is 3 and square root of z squared is simply z. Now it equals, we will use the law number 2. Okay, so this one, after using the law number 2, is gonna be logarithm x over y squared plus log of 3z. It is equal to, now now you will use law number 1, as we have the addition here, so it is gonna be log, and I'm pretty sure you already know that the result is gonna be like 3xz over y squared. So this is our solution of our task when we are supposed to rewrite the expression as a single logarithm. Okay, so as you can see, there is nothing really special about this. You just use all the three laws of logarithms or properties of logarithms, and if you have just numbers and you really want to evaluate the logarithm, you can simply use the change of base formula. Okay, now let's have a look on our task. On our last task, use the laws of logarithms to rewrite the expression in a form with no logarithm of product, quotient or power. So let me start with the first example. I'm pretty sure we're gonna use this, or we simply need to have this like on our left side of the solution, though I'm pretty sure we will not use all of them. So let's make some more space here. Okay, now let's do it this way. So we have all our laws here, and we can simply start solving our task. So this one, first of all, we want to get rid of the fifth root, so it can be written like ln, which means a natural logarithm of the expression x squared times z plus 1, the whole expression to the power of 1 over 5. It is equal to, we will use law number 3, which is then gonna be 1 over 5 times natural logarithm of x squared times z plus 1. Oh, I'm missing one parenthesis here. So now, as you can see, we have the multiplication here, so we will use the law of the product, so basically law number 1. When we do so, it's gonna be 1 over 5 times, let me put the parentheses here, a natural logarithm of x squared plus natural logarithm of z plus 1. It is equal to, now we will do the distribution, 1 over 5 times natural logarithm of x squared plus 1 over 5 times natural logarithm of z plus 1. It is equal to, now we will simplify this expression. We will use the law number 3. Okay, so law number 3. So it is gonna be 1 over 5 times 2 times natural logarithm of x plus 1 over 5 natural logarithm of z plus 1, which is equal to, we will now what can we do now? I think that's all, because we have no multiplication, no division, or no power thing here. So our result would be 2 over 5 times natural, okay, let me just write it without the multiplication sign, natural logarithm of x plus 1 over 5 times natural logarithm of the expression z plus 1. And we are done here. Okay, as you can see, and if you will really do a lot of training, you can skip a lot of steps in this solution, because you probably don't have to write this as a distribution, because you can probably see it, and you can really simply see that this quotient is becoming in front of the logarithm. So I'm pretty sure a lot of you, my students, can solve mainly all of the tasks I was solving till now little bit easier and faster. Okay, but as this is a video educating all of you, that's why it is a little bit more detailed video. So let's solve the last one, and again you can pause the video, try to solve it by your own, and then you come back and check your result. You can simply rewind the video, or you can watch how I will become to the result. Okay, so when I look at this expression, I would use the law number 2 here first. So let's use law number 2, which means this logarithm is equal to logarithm base 3 of 5x cubed take away logarithm base 3 of y squared, and this is equal to, now we will use the law number 1 for this expression. So law number 1, I would suggest, as I said before, you can solve it faster. So we will use law number 1 for this expression, and we will use the law number 3 for this term. Okay, so you can find very easily that our final result would be log base 3 of 5 plus 3 times log base 3 of x take away 2 times log base 3 of y. Okay, we really applied like all the laws, and we really made the solution like faster, as we would do it when we would apply the laws for each terms for each term, like step by step. Okay, I think that's enough for today. Thanks for watching, and see you during our next video. Bye bye.